here are the three dimensions of movement of an aircraft during the flight. The three axes, namely longitudinal axis, lateral axis, and vertical axis, are all straight lines which pass through the center of gravity of the aircraft, and the movement of the aircraft around these axes is based on the principle of the moment. So if you remember from the high school physics, moment is equal to force times the distance. Force is the hydraulic force or the manual force that we are applying on the flight controls, and distance is measured between the center of gravity of the flight control surface to the center of gravity of the aircraft. In order to increase the amount of the moment that we apply on the flight controls, we should have higher force or either longer distance between the flight control surface and the center of gravity of the aircraft, because the main and the basic of the movement is the center of gravity of the aircraft. This is why the manufacturers are trying as much as possible to place the flight controls in a distance or away from the center of gravity of the aircraft. Now look at the ailerons. They are far away from the center of gravity and located mostly near to the tip of the wing. So the three axes of the rotation or movement during the flight are the longitudinal axis, which is a straight line which runs from the nose to the tail of the aircraft, and the aircraft rolls left or right around this axis by the use of the ailerons and the flight spoilers. Then we have the lateral axis, which is a straight line which runs from one wingtip to another wingtip, and which also passes through the center of gravity of the aircraft, and the aircraft can have pitch up or pitch down, or nose up or nose down around this axis by the use of the elevators and horizontal movable stabilizer. Then we have the vertical axis, which is a straight line which also passes through the center of gravity of the aircraft, and the aircraft can have either nose left or nose right around this axis by the use of the rudder or rudders. Principle of the movement of an aircraft during the flight around these axes is all the same, starting from a very small single pilot aircraft ending to a very large commercial jet aircraft. They have the same principle. The only difference can be the size, the shape, and the location of the flight controls, which differs from one aircraft to another aircraft. Coming to Boeing 737 Classics, -300, -400, and -500, and all we have the same flight control system. There is not any major difference to talk about. The flight control system of Boeing 737 Classic is divided into two parts, the primary flight control system and the secondary flight control system. The primary flight control system is the ailerons, elevators, and a rudder. In the secondary flight control system are the left augmented flight controls, which are the leading gauge flaps and slats and the trailing gauge flaps. The primary flight control systems are powered by both hydraulic system A and hydraulic system B and standby hydraulic system. So the ailerons are both powered by hydraulic system A and B. Elevators are also powered both by hydraulic system A and B. Horizontal movable stabilizer is electrically moved, and then the rudder is powered by both hydraulic system A and B and also by the standby hydraulic system. The secondary flight control system, the trailing gauge flaps and leading gauge flaps and slats are powered by hydraulic system B, and besides, if the hydraulic system B is not available, then we can extend and retract the trailing gauge flaps by the electric power or by the electric motors, and the leading gauge flaps and slats we can extend them only by the standby hydraulic system. Just to make the presentation a little bit shorter, in this video we will only talk about the rule control system. So as a summary, the rule control system or the rule is around the longitudinal axis, which is a straight line which runs from the nose to the tail of the aircraft, passes through the center of the gravity, and the aircraft can rule left or right by the head of the ailerons and the flight spillers. Aileron system is powered by both hydraulic system A and hydraulic system B. The controls in the cockpit are the control wheels, which is in the left side for the captain, and the control wheel which is in the right side for the first officer. Then we have the aileron trim switches, and we have the flight control switches, and then we have the spoiler switches, which control the flow of the hydraulic or the pressure of the hydraulic on the flight spoilers. Now I present you a very simple example that what happens when one of the wheels is moved either to the left or right. Let's say the captain wheel is moved to the left. So what happens and how the aircraft is ruling to the left. When a captain is moving his wheel to the left, now this movement is transferred by the cables to the aileron power control unit, or the PCU, which is located in the left side of the main wheel well. And then if we put the aileron PCU or power control unit on the table and open all the attachments and bolts and screws and see what inside is, we have a drum inside, and the drum is controlled by two actuators. One actuator is for the hydraulic system A, or one actuator is powered by hydraulic system A, and then another actuator is powered by hydraulic system B. These two actuators are working in a synchronized manner, meaning that if both hydraulic systems are available, actuators are moving in a synchronized manner just to move the drum. When the drum is moved, then we have cables running to the left and to the right, and the cables are attached to the ailerons, and one aileron will be moving up, another aileron will be moving down. So if one hydraulic system fails, what happens? Let's say hydraulic system A is not available, and we have the hydraulic system A inoperative. Remaining hydraulic system is normally capable to move the drum in the aileron power control unit in full deflection. So we have normal the rule system, and we can rule the aircraft either left or right as much as we want, just up to the limit. What happens if both hydraulic systems fail, namely hydraulic system A and hydraulic system B? When both hydraulic systems fail, then we have a spring-loaded plunger. The spring-loaded plunger in the aileron PCU or power control unit will move down and will engage another drum, which is for the manual reversion. In this case, any movement and either left or right wheels will be transferred to the manual drum, which is also inside of the power control unit. In this way, we will move the ailerons manually. So in fact, we know that the forces will be higher to move the for example, the wheels either left or right because of the friction and because of the air load. Mainly the spoilers. We have two flight spoiler panels on the upper surface of the wing, and the flight spoilers are augmenting the ailerons. If the aileron movement is less than 10 degrees, the flight spoilers will be flush and they will not be augmenting the ailerons. But when the movement of the aileron is more than 10 degrees, now on the side of the wing, which is going down by the movement of the up ailerons, the flight spoilers proportionally move up just to augment the aileron. But on another side or opposite side, where the wing is going up by the down movement of the aileron, the flight spoilers will be flush. There will not be any movement of the flight spoilers. This is only to augment the ailerons. We know the function of the spoilers. Spoilers, besides helping the ailerons to better rule the aircraft either left or right, they have the function of reducing the speed during the flight by extending the speed brake lever to the flight detained. All four flight spoilers, two on the left wing, two on the right wing, in fact on the over surface, will move up in order to reduce the speed during the flight, or to help the pilot to have a steeper descent without increasing the speed. we have different systems of the cables which run from the control column. So mainly we can say that the Boeing 737 Classics is the cable that's not fly by wire like Airbus 320 or maybe like other types of the aircrafts. Mainly all the movements are transferred to the power control unit by the help of the cables. We have two systems of the cables. One system of the cable is running from the base of the control column of the captain to the base of the control column of the first officer. This is called the transfer mechanism. The transfer mechanism plays two important rules or two important functions. The first function or rule of the transfer mechanism is to transfer the movement of any wheel to the opposite. For example, if the first officer is moving his wheel to the right, same movement will be transferred to the captain wheel. This is the first function of the transfer mechanism. The second function of the transfer mechanism is in case of the cable jam, because we know that the cables are running from base of both control columns aft to the PCU and to the spoiler mixer. So if in any place the cable is jammed and there is not any movement, so the pilots will apply force on both wheels, and this way the transfer mechanism will cut the connection between the captain wheel and the first officer wheel, and wheels will be operated just separately. So later we will look at it, what happens and how this is done. Another set of the cable is running from the base of the control column of the captain aft to the aileron PCU or power control unit, which is in the left main wheel well. So any movement of the for example wheel from the control column of the captain is transferred by this set of the cable to the aileron PCU power control unit, just to signal the actuators how much they should move and how much the drum should move in the PCU, and then another set of the cable from the drum will be moved both sides to the ailerons to move the ailerons up or down. Then from the base of the control column of the first officer, a set of the cable is run aft to the spoiler mixer. This is very important to know why we call it spoiler mixer. Actually, we are not calling it spoiler mixer. Manufacturers are calling it mixer. Why it is called mixer? Because any movement of the wheel, maybe the captain or the first officer, besides being signaled by the cables to the aileron PCU that we said before, is also signaled to the spoiler mixer. So now here the spoiler mixer will evaluate this movement. If this movement is lesser than 10 degrees for the ailerons, this mixer will not sense any signal for the flight spoilers. But if this movement is more than 10 degrees, the spoiler mixer functions three things. First, it senses that the movement is more than 10 degrees, and second, it senses the movement is to which wing. It just actually finds which wing is going up, because which wing aileron is moving up and which wing aileron is moving down. So in the wing where the aileron is moving up and the wing is going down, then the spoiler mixer will signal through the hydraulic actuators to those flight spoilers which are at the upper surface of the downgoing wing to move proportionally, just to help the aileron. And then it will not send any signal to the spoiler panels or the speed brake panels, or we say the spoilers on the upgoing wind where the aileron has moved down. This is the second function of the spoiler mixer. The third function of the spoiler mixer is during the roll or turn. Let's say, for example, we are turning 20 degrees to the left. In this case, so in fact, in the downgoing wind, the two panels of the spoilers will move up to help the ailerons. At the same time, if you want to decrease the speed and we extend the speed brake to the flight detent, now the mixer will signal all the flight spoilers, namely on the left wing and on the right wing, to move up, because now it helps the pilot to have better roll and helps the pilot to reduce the speed. Now the mixer will signal the speed spoilers to the spoiler panels on the downgoing wind to move more than the spoilers which are on the upgoing wind. So these are the three main functions of the spoiler mixer, and why we are calling it mixer, because it mixes up or the different movements, different degrees of the movements of the ailerons and the speed brakes if we apply during the flight. So as we said before, if we lose one hydraulic system, let's say hydraulic system A or B, remaining hydraulic system will be able to move the ailerons and full deflection, so there remains nothing to worry about. But if we lose both hydraulic systems A and B, what happens now? In this case, in the aileron power control unit, we have a spring-loaded plunger. The spring-loaded plunger will engage another drum by the help of the spring, because as long as we have hydraulic system available, maybe both A and B or maybe one of them, the spring-loaded plunger will be up and the drum which is installed for the hydraulic pressure will be operational. But when we lose both hydraulic systems and both pressures A and B will be reduced on the PCU, then the spring-loaded plunger will be coming down by the force of the spring and another drum will be engaged. Now this drum is for the manual reversion. So in this case we can normally, actually we cannot say normally, but we can still rule the aircraft, but excess force will be required on the wheels to move or to rule the aircraft to the left or to the right. This is because of the friction and because of the air load. One common mistake that the pilots are making during the manual reversion is that because manual reversion is not a normal exercise to practice in each and every flight. Sometimes during the simulator we are practicing the manual reversion having both hydraulic systems failed, but rarely it happens during the flight to practice the manual reversion. One common mistake of the pilots is that they are expecting the same rule rate in the manual while they are ruling the aircraft manually without having any hydraulic system. Expect a later response from the aircraft. For example, if you want to rule from the heading of, let's say, 270 degrees to the heading of 180 degrees while we have hydraulic pressure available, normally we can rule and beautifully we can turn in any degrees that we want, 10 degrees, 15 degrees, 25 degrees or 30 degrees. But during manual reversion we should expect late response from the aircraft, because when we manually moving the ailerons, so there will be another arrangement on the aileron. Let's say the aileron which wants to move up first, the top which is at the trailing edge of the aileron first will move down, and the air force on the top will help the aileron to move up. So this needs some seconds to get the sense, and then the aircraft will start turning. Then when we reach to the heading of 270 degrees, at least 15 to 20 degrees before this heading, smoothly and abruptly we should apply the opposite aileron and let the flight controls. So here the ailerons to get the response, and then the rule out the aircraft and maintain that heading. This is the common mistake that we are making mostly. And it has been seen during the simulator sessions also that when the both hydraulic systems are failed, the pilots are with the wheels, they are fighting with the columns just to move the ailerons and just to have a rule the same as when they have the hydraulic system available. So this is something practice that the pilots should do during the simulator to get the benefit of the habit how they should turn left or right while the hydraulic systems are totally failed. Now, as we talk regarding the transfer mechanism, that we said that this system of the cable arrangement between the base of the control column of the captain and the control column of the first officer, the transfer mechanism plays two important rules or functions. First, it will transfer the movement of one wheel to another wheel, and the second function of the transfer mechanism is to separate the columns just as a separate unit. How it is done? Let's say if there is a cable jump, because the cables from the base of control column of the captain and the base of the control column of the first officer are running aft, One is connected to the aileron PCU power control unit, and the second is connected to the spoiler mixer. So on the way the cables are running from the base of the control column to the PCU to the spoiler mixer, they run through the pulleys, they run through the different angles and directions. Sometimes it happens the pulley breaks down and then the cable is jumped. So as much as you try, you cannot move the wheels either to left or right. In this case, both pilots, based on the non-normal checklist, both pilots take the wheel and they apply maximum force on the wheel, and suddenly a sound of the click is heard. The sound of the click means that both columns are disconnected from each other. Now we should know which system is available now. Either we have only the ailerons available, or either we have only the spoilers available. Impossible to have both available, because a cable has jumped, maybe the PCU or maybe the spoiler mixer. If movement of the captain wheel will rule the aircraft left or right, this means the captain wheel is operational, and immediately captain will become the pilot flying, and we are ruling the aircraft by the ailerons. But if the movement of the wheel of the captain does not bring any rule on the aircraft, this means the cables which run from the base of the control column of the captain to the aileron PCU power control unit has jammed, and now we do not have any ailerons available. Now the first officer will immediately become the pilot flying, and the only flight controls which help us to rule the aircraft will be the spoilers, or the flight spoilers, two panels of the flight spoilers. Now we do not have the ailerons available. We have two switches that control pedestal for the trimming of the ailerons. Before to talk about these two switches, we should know what the function of the aileron field and centering mechanism is. That's a very simple mechanism. That's two or three arrangements with a spring inside, and the function of the field and centering mechanism is to give artificial feeling on the wheels. So same as the car wheel, so when we move the wheel to the left or to the right, we should have little bit artificial feeling. We should have a feeling of the control wheel. The wheel should not be so smooth. So the feeling on the wheels is brought by the field and centering mechanism, which is attached near to the aileron PCU or power control unit. This is the first function of the field and centering mechanism. The second function of the field and centering mechanism is to trim the ailerons. For example, if you want to trim the ailerons, one aileron down, one up, so movement of both switches will electrically signal the field and centering mechanism, and the field and centering mechanism will move from the center position either a little bit to the left or a little bit to the right. So this is going to be a change on the flush position of the aileron, and then we will have a new position for the aileron, which is not going to be now flush with the wing. It's going to be a little bit up, and opposite aileron little bit down. This is the new position of the aileron. Then any movements to the left or to the right on the control wheels will be transferred back to the field and centering mechanism, and then the aileron will keep this trimmed condition until we bring the trim back to zero. And the scale to trim the aileron, or to know how much the aileron has trimmed, is at the top of the control column of the captain and at the top of the control column of the first officer. Once we trim the aileron, the control wheels will be little bit displaced. If we trim to the left, the wheel will be displaced to the left, but this is going to be the neutral position. We should accept this as a neutral position. And if we trim to the right, the wheels will be moved to the right little bit. Again, this is going to be the neutral position of the wheels, because we have trimmed the ailerons. They are not now flush with the wing. And while the autopilot is engaged, trimming the aileron is prohibited. Why? Because as long as the autopilot is engaged, the autopilot will keep the heading, will keep the track of the flight, so the trimming of the aileron will not have any effect on it. In this case, the wheels will not have any movement. Still they will be centered. as long as we trim the ailerons by the switches. But once we disengage the autopilot, a sudden turn or roll will be encountered or felt, because the field and centering mechanism has already got the signal to trim the ailerons, but the autopilot is keeping it back to the neutral position. Once the autopilot is disengaged, the spring will force the field and centering mechanism to rule the aircraft to the amount of the trim that we had brought by 2 switches. As we talked about the flight control switches, where they are on the overhead panel in the cockpit, and we have 2 switches. They are labeled A and B. The A switch is to control the flow of the hydraulic system A to the primary flight controls, and the B switch is to control the flow of hydraulic system B to the primary flight control system. The switches has 3 positions. The down and guarded is the on position, then in the center we have the off position, then in upside we have the standby radar position. So if we place the switch from the guard to the center, which is the off position, in this way we cut the hydraulic pressure to the primary flight controls. But based on the non-normal checklist and the procedures that we have in the non-normal checklist, mainly when we get any hydraulic system failure, system A or B, the normal position of switch should be in up, which is the standby radar, because in this way we are turning off the hydraulic shutoff valve, and the flow of hydraulic to the primary flight controls will be cut, but still we have the standby hydraulic system available for the radar, for the movement or operation of the radar. One common problem associated with the rule control system is the unavailability of the hydraulic system, either A or B. So during the flight, if for example the flight control light is eliminated, this is an indication that the respective hydraulic system is low. In fact, the pressure is low on the primary flight controls. Based on the non-normal checklist, the position of the switch should be moved from the down guard position to the standby radar position. Now we lose the hydraulic pressure to the primary flight controls. As we discussed before, we have radar hydraulic system available to move the flight controls. But if both low pressure lights, the flight control low pressure lights illuminate, this is a clear indication that we lost both hydraulic systems. In this case, both switches should be moved to the standby radar position based on the non-normal checklist. Ailerons, elevators will be moved by manual reversion, and radar will be moved by the standby hydraulic pressure. This way, to continue the flight to destination is not recommended. So if we are very near to the destination, that's okay, we can continue. But if we have longer way to go to the destination, to continue the flight is not recommended, because we will not have the autopilot available, and all the controls along the longitudinal and lateral axis will be manual. Only we will have the radar available through the standby hydraulic system. So the bank should be limited to 15 degrees, and landing should be made to one of the suitable airports as an alternate, with the flap 15. The trailing edge flap will be extended to 15. This is the only possibility for the pilot to keep the aircraft safe and not to bring undue stress on himself to continue the flight to the destination. Because in manual reversion, so as we talked before, there will be late response on the flight controls. That's not only a matter of turning during the flight, how much degree you want to turn, but for the landing also it's not going to be just a normal practice, because in a failuring maneuver for the landing will be a little bit difficult. Just elevators will not give us proper response. There's going to be a late response on the elevators, and during crosswinds and some other conditions, there's going to be a challenge for the pilot to make a smooth and normal landing. Another problem encountering with the rule control system is jammed or restricted flight controls. As we talked before regarding the jammed cables, maybe from the base of the control column of the captain or the base of the control column of the first officer, sometimes it has been recorded in 737 classics that due to the freeze of the water or the icing on the aileron control surface, the pilots feel that there is not free movement or normal movement on the wheels. In this case, the best way is to disengage the autopilot, disengage the auto throttles, get the controls manual, and both pilots should force on the wheel in one direction, not opposite directions, either to the left or right. If the jump was due to the ice on the aileron panels, then the panels will be released and then normal movement will be back to the wheels on the left and right. But if it was due to a cable jam or maybe the flight control surface jam, then has the scenario we talked before, there will be disconnection between the wheel of the captain and the first officer, and then the rule will be only with the ailerons or will maybe only with the flight spoilers. So thank you very much, friends, being with me in this video. We had a summary of the rule control system on Boeing 737 Classics, and we had some little bit deep look on the technical sides, also having a deep look on the PCUs and the spoiler mixers. I think this rough information is beneficial for the pilots to have in their minds how they are ruling, how the airplane is responding to them. And please be kind to leave your comments in the comment box of this video, any questions that you have, and please wait for my next video, and we will continue with the flight control systems with two other systems, the pitch and the yeah. Thank you very much, and see you in my next video very soon.